Okay, so from thinking about these logs that were invented, like from an historical perspective, the reason they invented them was to try and make really hard multiplication easy. And so it turns out that if you want to multiply two numbers together, it's the same as just the log of two numbers multiplied together is the same as the log of one number plus the log of the other number. And so logs was really powerful because it turned long, complicated multiplication that you couldn't do in your head into addition. And then we just had tables with like all the different log values on, like log of 1 is this, log of 2 is this, log of 3 is this. It was like much more detailed, like log of 1.001, log of 1.002. Just look up your number and you could log it and then add the two logs together, unlog it, and you'd end up with your answer. And it was the same for division. The log of the one number divided by another, logged, is the same as the log of one number minus the log of the other number. Those rules are still really useful for us algebraically, right? They let us combine the different logarithms together. And so we can rewrite log of xy as log of x plus log of y. We can rewrite log of x over y as log of x minus log of y. And there's this rule here which is really useful for grabbing if we're logging something that's got an exponent, we can take that exponent down out of the log. Look, so log of x to the n is the same as n log x. Those rules, luckily for you guys, are all on your formula sheet, so you don't need to remember them. What we need to do is get really familiar applying those three log rules to solve equations. They're particularly useful for equations that have got exponents in them because it lets us pull the exponent down out of the equation.